Hi, Doctor. Our group project is password security checker system. Our group member have Han Yaohui, Lim Shaojian, Ding Qingyan, and me, Bang Qizhi. We have 4 content and 6 part. Introduction. A password security system is an automated authentication mechanism that grants access to authorized users after verifying their credentials, such as password, pins, or passphrase. This system helps protect sensitive information, personal data, and digital resources from unauthorized access. It can be applied in various environments such as computers, online accounts, and secure facilities. We use multiplexer we call MUX, combinational logic circuit that selects one input signal from several input lines and transmit it to a signal output lines based on select inputs. Second, regular logic circuit. The password security checker is designed to verify user input and make logical decisions based on password accuracy. Third, flip-flop. Basic memory element used in digital circuit to store and maintain a binary state, either logic 1 or logic 0. I pass to my friend.
From my partner, Pang Qizhi. Next, the password security system in this project is designed with 3 main objectives. First, if various user input touch a keypad panel labeled from 0 to 6, where the correct password secure is 0521 based on the IC number 000520011225. The internal logic circuit built using AND GET and NOT GET along with multiplexers compare each input set by set to ensure that only the correct order allow access. Second, when the user complete the input and press a verify button, the control circuit compare the enter digit with a stored password. It is secure because the logic control output a high signal to the output unit, which activates the access mechanism or light up a green LED indicating access granted. If the password is incorrect, the circuit maintains a low signal, keeping the system locked and activating a red LED alarm to signal an error. Third, to enhance system security, a built-in protection mechanism monitor incorrect password attempt. If the user enters the wrong password more than 3 times consecutively, the system automatically triggers an alarm to warn out possible unauthorized access. Additionally, the system includes comprehensive input handling logic that continues monitor all buttons, process to ensure they are within valid limit. It detects multiple or invalid key pressed on trigger and error condition or temporarily log out when necessary. During that error state, the verification process is disabled, preventing any output signal from activating the access indicator. This ensures that not unauthorized user can gain access until valid input is re-entered. Overall, the password security system provides accurate verification, reliable operation, and strong protection against misuse of instruction. Next, I will pass my handsome partner Han Yaohui to explain the system A.
Okay, thank you, Lin Shaojuan, for our beautiful partner. So it's explain and briefing the our objective or our main group project. So now it's my turn to explain our system A, of our password security checker system. So this is one of the most important part, the beginning of the whole system. So okay, let me simply explain. So based on this slide, okay, when user press the authorized password, 0 in first multiplexers, as called as MUX mods, 5 in second multiplexers, 2 in the third multiplexers, and 1 in the 40th of multiplexers, password security will allow users for granting access to the system. Okay, as you can see, this picture we already provided in here. Okay, you can see 4 of the multiplexers, 1, 2, 3, 4, and 1 engage. And this one, as means the output then show up pass through is output 0 or 1 that can allow the users for granting access to the system whether or not. Okay, now we can see. Okay, let me explain the simple first. So you can see, you go to one arrow, right, and lots of a line here, and then we'll go 1 and 0. What does that mean? 1 is mean a high level. It's mean maintain a high energy. And then this wait a minute. Okay, this 0 0 means it's a low level. It's mean a low energy. So it's mean like some kind of like ground level. So okay, and you can see this code 1, code 2, code 3, code 4. Okay, these 4 codes combined together as mean is one password. So we just put that is called as code 1, code 2, code 3, code 4. Okay, now you can see. So the first multiplexer we put 0 as going to the high level, and the second one is a 5. The third one is a 2, and the fourth is 1. So okay, what's the concept? Okay, these all multiplexer, they must show up the output. Okay, it means, okay, for example, for the first multiplexer, okay, we key the right password, right? 0. So it's going to show the 1. 1 is mean high level, high energy. So going through this line, going to the end gate, and go on. Okay, the other 3 multiplexer also same. Is key the right passcode and key the right code and combine together. It mean the right password and going through this engage, so we can show up 1. It means allow the user for getting access to the system because we know the best the concept of engage. So it means you know the concept of engage is the any input that connected to the engage must show 1. So if all the inputs is all the inputs is allowed to result output is 1 going through this engage, and then the engage will going to produce the output is 1. So we're going to can allow the user to for getting access to the system. Okay, now okay, our password is 0521. This is a right password in the right sequence way. Okay, now I would like to share the deep software that's for explain what if we key the wrong password or the password in the wrong second way. Okay, I'm going to share. Please wait for a while. Okay. Okay, so everyone can see my dips. Okay, so okay, daughter can see my dips. Okay, okay, okay. This is the our whole system lah. But we just simple say to go. We say the multiplexers is system A first. Okay, please wait for a while. Let me put the breaker. Okay. Okay. So as we can know, let me start the animation. 0. Okay. Wait. 0, 5, 2, 1. Okay, that's a right password, right? So verify. Okay, just simple showing first. We are not having explaining, but we show simple. You can see this all is the input. The output is 1 going to this. Okay, it means it's passed through. Okay, 1, 1, 1, 1. Okay, okay, and down, and then we show up. Verify first again. User activate. It's okay. It's mean there's a right password. Okay, what if we key the wrong password? It means okay 09 A. Okay, we verify again. Okay, that's incorrect. Okay, if okay, if our password is 0521, right? Okay, if we key in the wrong sequence way, so it means 50 okay 21, okay, some kind of that. We verify again. Okay, it's incorrect. This means we need, okay, the small conclusion is we must to show out our this multiplexer. So we want to make sure we key the right password in the right simple way, so can go through the end gate and show out the output is 1. Okay, that's a simple one. My simple explanation for this system A. So now I'm going to share again back to the slide for explain the truth table. Quickly to explain the truth table. Wait. Please wait for a while. Okay. Okay, got it. Okay, pardon. Okay. Okay, this truth table one. Wait. Okay, truth table one. Okay. So okay, we got A, B, C, D, right? So A is mean multiplexer 1, B is multiplexer 2, and go on. So 3, 4, C 3, D 4. Okay. So we need to make sure A, B, C, D. Okay, for simple to explanation, simple conclusion. Okay, we need to make sure all the A, B, C, D, these all multiplexer go key the right password and in the right simple way. So it will show out the output is B, the output is 11111. So the output is 1. So it means we can create in the system B for the creating the system B. And then I'm going to explain. Okay, this is our K-mate. So you can see as we can conclude that. So 1111. Okay, the only one, right? So doing the SOP. So we got the output for the most simplified Boolean expression is equal to A, B, C, D. Okay. So okay, there's a POS. Okay, there's a difference. We can conclude that. So A bar plus B bar plus C bar plus D bar. Okay. Okay, there's a truth table 2, input of result of multiplexer to open activate the system. So X is system A, total result of 4 multiplexer. Y is verify enter, Z is electric. So X, Y, Z. So okay, this I will explain it with a letter. So now I'm going to pass my mind and say to Ding Qingyan, our handsome partner. Okay.
Okay, thank you, Han Yahui, for explaining the system A. Now I will want to explain my system B. The system B has two parts. Is open system and alarm system. Now I will explain the open system first, and alarm system I will give my partner Han Yahui to explain. So the open system is when user press the right password in the right sequence where 0521 is system A, the electric are turned on and the users press to verify the password. It will activate the machine and the green light will be turned on, then starting to count out the machine activate timer in 50 seconds. Now let me show my disk to show with total how the disk to work. Okay, this is our group project for system. So when I start to present, when the code is open and I already put the right password, directory open, and I will modify, they will be open, and now it's until the 15 seconds, it will be closed again. Okay, this is my our open system. The open system have open 15 seconds and 50 seconds and already closed. So when the user need to open again, he will be change the modify to 0 and change the modify to 1 and open one more time. So let me explain the free fall how to work. So first, the Rust is control the clock to control the clock free fall. So when is output is 0 0 0 is out the 0 low energy and pass the value to the NAND gate and he will pass the enable for is. Okay, when the enable is 1, so the So the D is 1, so the clock can the Q is output is 1 0 1 0 for the JK4. So the Q, the rest of output Q will be linked for the clock for JK4. So when our timer is until the 50. Okay, when the timer is until 15, there must be all JK4 output is 1111. So when all input is 111, they will change to the raw energy and they will enable is become 0. So even the core is already there high low there also not have become the Q. Q is also 0. So the core the before has no function and the get is for of course. So when we enter the right password and I already open the electric and modify. So the modify has been go in the high input and electric high input and mass is high input. So when the all high input, there will be prepare the high input to the queue. The JK4 will become the toggles. So when the is also same everything. So how do I can control the is activate is open is 1 or 0. So when the is 0 0 0 0, it will be become so the first no. So so the first is 0 0 0, right? So 0 0 0 or change to the 1. So the activate is become 1. So when it was 1 clock, so he was 1 0 0 0. So it is a 1. So when 1 0 0 is become 1 already. So when he arrived at 50, so he is the output is 1 1 1. So when the 1 1 1 already okay, it is too high. So they will change the input row to the engage and it was be activate to the 0. So this is our open system. So let me to explain our truth table. Okay, this is the truth table for the JK54 one. So it is the Q0, Q1, Q2, Q3, right? So I will see the this. When I see the this, it is Q0, it is Q1, it is Q2, it is Q3. When the 1001, so this is 9, this is 9, right? So when the 1001, they will decimal count is 1, so the timer on is activate and T will be become 1. When until the 50, they will be 1111, they will be decimal count is F, so it will become the 0. Okay, this truth table is our free for output F this is our FF0, this is our FF1, this is our FF2, this is our FF3. So the output is already is Q. So when our reset again, okay, when our is 0 0, right? So the output is Q, FF0 is Q is 0, FF1 is 0, FF2 is 0, FF3 is 0. So is this FF01, FF0 is 0, 0, 0, 0. So if I put again clock, so this become the 1, 0, 0, 0. So the flip 4 is 1, FF0 is 1, and FF2 is 0, FF2 is 0, FF3 is 0 again. So when the output is already okay until 50 is become the 1, 1, 1, 1. So why the flip 4 is become 1, 0? 01 and 11 and 001. It because and when the output is 1, so this will be decade 4 is become the 1 first. Let me see. It's become 1 right? So when I call again, call 1 time, so this check, this is 1, so the output is 1. And also pass the value to the second 5411 J and K. So this also is 0, but the next time it will become 0. Okay, the next time clock is arrived, so the 0 has been become that is 340 has been become the 0, and the J and K have already last time have passed the value 1 right, so it will become the 1. So when I put again, it will become the 1. When the 234 it become 1, they will pass the value to 342. They will be give the value J and K is 1. So when I put again, they will be the 1. There will be a 1 and D will reset to the 0. So according this system, so we can control the counter to become the 1, 2, 3, 4, 5 until the 50th. Okay, this is my part to introduce the open system. I will pass the mic to my partner Han Yaohui to explain the alarm system, what to work and how to work. Thank you, Doctor.
Okay.
Okay, thank you, our handsome teammate Ting Qian, to explaining the part of system B that for activating the system. Okay, so now it's my turn to talk about the system B that what going to happen will turn on the alarm mode. Okay, first of all, think about that. Okay, because our machine, no, I mean our system is called password security checker system. Okay, so for example, I going to use the real life, the real word that things that use maybe will related to this password security checker system. Okay, so I showed the smartphone. Okay, yeah, I'm not sure you can see it. I'm not sure everyone can see it. So this smartphone, right? So when you press inside, you need to how to unlock your phone because it got password, right? Okay, so for example, maybe my password is 1234. Okay, but I key wrong time the first time. Okay, so the system will allow the user to repeat to key again the password, to give the chance, give the opportunity to key the password again. So I key 0102. Oh, wrong password again. Okay, the second time. Okay, the system will give a chance again to the user to key the password, the right password in the right second way. Okay, so the third time is like 4321. Okay, wrong password. Wrong password. Okay, the wrong password because it's a wrong second way, right? Okay, so already 3 times, right? So what's going to happen? So we see like maybe the phone will going to give a sign, and you will not allow the user to key the password again, and give the sign that's in it's right. Okay, you might to try again to key the password in 1 minute. 30 seconds or 50 seconds depends on the system, the machine gives you the instruction. Yeah, according to the machine. Yeah. So now this is a real life example. So now I'm going to explain based on this slide for my part. Okay, system B. When user press the wrong password exit 3 times, password security will go alarm mode to protect the system. So the alarm will be activated with turn on the red light. Okay, so actually because as I give the example, so when we use a smartphone, we want to unlock it. So we need to give the password in if key the wrong password exit 3 times, depends on the machine. Already 3 times, and then you show up going to alarm mode or something like show up something sign that you cannot going to make the machine into the protective mode, alarm mode and protective mode. Basically, it's mean like protective. We protect the machine. We protect the things. Anything else depends on the machine. What's the purpose of the machine? So okay, as you can see in this picture, okay, as we show out. So okay, multiplexer. This for multiplexer, electric, verify. Okay, this four ones. Okay, okay. Our password is what? 0521. 0521. Based on our IC numbers that we have used it. 000510011225. So our password is 0521. And now what's shown in this picture? The password, the code is in the password lah, is 1026. Is it right or wrong? Wrong. It's a wrong password. Okay, so okay, as I already explained, so this four multiplexers must show the right the right code, so the right password in the right second way. So it's going to make the engage to show the input is the output is one. So the entry of course is open now, it's turned on, so it means it's one, and then we need to verify. So we press a button, it's one. So it's all going this three. We're going. Oh, sorry, pardon. Sorry. Okay. So these three, we're going to combine together. We're going to show the make the. We're going to make the whole things going to show up there's artifact or going to show the incorrect. So okay. So okay, as you can see that in the picture, this already incorrect three times. So what's happened is going to show the button that the alarm mode. You're going to show the alarm mode. It means also is turn on the red light. The red light just a symbol. Not it mean all the things, all the system will show out the red light. But maybe in other ways will show out the sound of buffer or the sound alarm. Depends on the machine. So the red light just a symbol. But we're going to say the alarm will turn on. It means you already key the wrong password several times. So it's going to the protective mode or the alarm mode. So now I'm going to show the dips to show my we're going to show the dips software. So I'm going to explain the process, the action way. We can see the use the what's how to happen for this multiplexer to no I mean multiplexer actually verify going to this and make the alarm mode happens. Okay, please wait for a while. Okay, present something else. Windows. Okay. 3, 2, 1, go. Okay. Okay. So everyone can see. So sorry. So everyone can see my slide. Okay. Okay. So okay. There's a whole. Okay. There's a whole part. Okay. Wait. Okay. 0521. Okay. There's a right password. Okay. There's an electric. There's a verify. So if I verify this password is right, it will show the activate. Okay, so also will count out for measure to store the activate. Okay, that's the part my teammate Tinqian already explained. Now it's my turn to talk about the alarm mode through this deep software. Okay, now I'm going to press key the wrong password 039D. Okay, now I verify it. Okay, it's already shown the incorrect, right? It's one. Okay, the first time we key the wrong password. Okay, so the system gives the chance to the user to key again the password to activate the system. Okay, now I key. Okay, maybe D3 2 1. Yeah. Okay, 1. Okay. Now I verify again. Oh, okay. The second time, oh, wrong. You key the wrong password again. Okay. Kinjana. Okay, it's okay. Let me think about. Okay, I try again because the system give me a chance again. Okay. So maybe I key 1, 2, 5, 0. Like my password, maybe like that. Okay. Now I verify again. Oh, incorrect. Hey, what happened? You will see this below. The alarm is output is 1. This means we active the alarm. We active alarm. It's show out the red sign, the red light. We turn on the red light. So oh my god. So the whole system is going to the protective mode and the alarm mode. So there's a way how to this process going, how it happen. So okay, okay, for I'm going to say small details. If you can see this end gate in here, that between this multiplexer and this verify. So okay, why this a function actually? Okay, I'm going to say the details of this gates. Okay, actually just four multiplication connect to this. Why this need to going to connect to this and the verify but one of the line connect to this. The function okay I simple to explain that. Okay, this AND gate actually the function is when we key the incorrect password and that's okay incorrect password and then how to can make when we key the right password in the right single way, how can we make this going to the activate? I mean to the correct part, to activate this, activate the system. Okay, so for example lah, for example, okay, so I key this, okay, I key back the right password, right? 0521. Okay, now, okay, I verify it. You're going to activate. Okay, so if okay, for the first time, maybe lah, okay, for the simple show the way. So I need to verify, right? The password is right or wrong. Okay, I verify it. Wrong. Okay, the second time, okay. Okay, I remember my password is 0521. Oh, it's going to activate. Yeah. Actually, that's so going to activate. So that's the way they engage the purpose of this engage. Okay. Now I'm going to share where. Now I'm going to share the mouse slide. Okay. You can see here. Is wait. Hold on. Wait a second. Okay. These are my slide. Okay. Our slide. Okay. I simple to explain for the true table of 2 and 3, it means just only 2 because 3 already explained by Ting Qing Yan, my teammate. Okay, now to true table 2. Input of result of multiplexer to open and activate the system. So X, Y, Z. X system A, total result of 4 multiplexers. Y is verified, the button to, and the button is mean to enter, is mean to verify. Z is electric. Okay, so simple explain for this whole true table. Okay, so first of all, X, Y, Z. Okay, first you want to know Z is electric. Electric is must to open for whole time. So it means if you open electric, your system can process, can go and conduct the activities. If the electric is not open, how we can to do whole things? Is that logic, right? Okay. So now, okay, X, Y, Z. Okay. So X system A. What is system A? I explained for that part. So it means that part system A is mean the multiplexer. What does that mean? The password. The place we set our password. We set our password. What is our password? So if the system A, all the input is 1, so we show the X. Now we show the truth table, the X, the output is 1. So if the one of the password is wrong or how the password is wrong or also not in the right second way, it's a wrong second way, in the wrong second way. So it's not going to show the output of the X is 1. So it's a 0. So the wrong password also of course cannot do anything. So we cannot activate the system. So okay, so I'll say a simple for the Y verify enter. You must press the enter so you can accept to make sure your password is right or wrong. Okay. Now if you connect to this true table, okay, X Y Z, you can see the whole one just only one rows is show the output is 1. Because why? Because X Y Z you are the Z your entry is open. Y Y as okay I explain the X first. The X your password is right. So show the 1 and Y you verify the password. So it's 111 it's got 1. The other than that all is 0 because if you miss one of the part it's not 1 it's not showing anything. It means you cannot activate the system. You cannot open the system. Yeah, so that's the truth table that we can see the simplified one. And now we expand the last one. The last one, okay. So for the truth table, 2. So the KMAC already show up. Okay. Okay, you can see S, Y, Z. Okay. The only one is 1111. What's 111? Based on our truth table, 111 is what? S, Y, Z, it show the output is 1. The middle output is 1. And then we got the output is 1. Okay. So as based on the truth table and this KMAC, we can conclude our Boolean expression. The output of the Boolean expression for the activate the system is X, Y, Z. Okay, just that. So that's my part for explaining the system B of the activate the alarm mode. And now I'm going to pass my mic to our beautiful teammate. Okay, Ling Sao Jen. Okay.
Okay, thanks for Han. Next, the password security system is a digital protection schedule designed to control access to electronic device. It allows a user to activate a system only when a correct password is entered. If a wrong code is entered, the circuit automatically trigger an alarm to ensure safe. In design this system, we use truth table and KMAC to simplify the logic equation to minimize the number of get used. The system may work based on two key Boolean expressions. Input of system A for granting access to system B and activating the electronic device which show the Boolean expression is ABCD multiply XYZ multiply Q0 plus Q1 plus Q2 plus Q3. Next, this part check whether the enter password is correct. When the full password bit ABCD and the control input XYZ meet the request condition, system bit is enabled, allowing the connected electronic device to operate. Alarm input logic to trigger the alarm when the password is incorrect, and the Boolean expression is A bar plus B bar plus C bar plus D bar multiply X bar YZ. This logic ensures that if an invalid combination is entered, the alarm signal is activated. In the finally circuit diagram shown in the picture, first, the left section represents the password input models. Next, the middle section performs logic comparison and decision making using and get and not get allowed with multiplexer. Third, the right section gives the output signal, either granting access to device or triggering the alarm system. The structure ensures accurate password verification and reliable system response. Next, the password security system can be applied in many real-world areas, such as digital door lock system. This used in home, office, and lab, where door unlock only after the correct password is entered. The ATM and banking system. This can similar password logic ensures secure access to bank account and prevent unauthorized transaction. The electronic sex box and locker protect valuables and documents, only opening when the correct password is entered. Next, microcontroller and embedded project. This can help students and engineers understand real-world authentication system. Last, industrial access control. This can restrict access to control panel or mechanisms to authorized personnel only, improve safety and security. For my part, we can conclude that the password security system combines digital logic design with real-world security application. By using balance simplification and a system that is simple, reliable, and efficient, it ensures that only authorized users can access electronic devices while providing automatic alarm protection for warm attack. Next, I will pass my partner Pang Qizhi.
Conclusion: the password security system project successfully demonstrates how digital components such as multiplexer, flip-flop, and logic gates can work together to create a secure and reliable authentication process. Through the use of a 4-digit password 0521, the system effectively validates user input before granting access, ensuring that only the correct combination activates the output. The project also highlights how digital logic can be applied in real-world security systems to protect data, control access, and prevent unauthorized use. Future improvement could include upgrading the system to accept alphanumeric or decimal input for easily used interaction, integrating display feedback, and enhancing memory feature for greater flexibility. Overall, this prototype demonstrates a strong foundation for developing more advanced and practical electronic security systems. Thank you, Doctor, for listening our presentation today. Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.